Hello there, and thank you for joining me today. This is a video on the Marconi 2955R radio test set. There are various models in the 2955 range. There was a Marconi 2955, which was the first model that was brought out. Looks exactly the same as this test set, except it has a 30 watt RF port. This is a 75 watt one. Then there was a 2955A model, which is identical to this again, except this TX monitor button was blanked out, so it didn't have any function. Then came the 2955R model. So the 2955A and the 2955R, which is this model, had the 75 watt port as well, incidentally, but the 2955A had this blanked off. The 2955R, which is this model, had the TX monitor capability, so that blank button then had the TX monitor, so you can listen to signals off air on an antenna plugged onto a low power port. And then after this test set came the 2955B model, which was a white test set, much like the modern Marconi Aeroflex IFR test sets are today, except the buttons were rubberized and it was more modern looking in comparison to these. These test sets were first produced in the late 1970s, early 1980s in the UK. They were primarily manufactured solely for the purpose of testing radio communications equipment that was supported by the Home Office Directorate of Telecommunications, or DTELS. And DTELS was an organisation in the UK which was part of the Home Office, the central government, which looked after the maintenance of all telecommunications equipment across all government agencies. And so rather than having separate signal generators, mod meters, power meters, Marconi was briefed to create a design to produce an instrument that had all those separate instruments built into one unit, and thus the era of radio communication test sets was born. And this radio test set was manufactured in the early 1980s in Chelmsford in England, I think. And one of the features of this test set, which I do like about it, is the fact that it's very proven reliable. There aren't many test sets that are out there that have lasted as long as this model has, the 2955. It really is the workhorse of RF testing in the world of RF, and it's very well known across the world as well. And for its age as well, it's very advanced in comparison to even modern test sets. You'll find some of the features on here obviously on modern radio test sets as well, and this is where a lot of that technology and thoughtfulness came from, was from the Marconi Instruments range. Okay, so first things first, we'll switch it on. Like any radio test set, you must allow it to settle once it's switched on before you start doing any maintenance measurements or anything like that. It has its own inbuilt reference oscillator. You can use an external reference source that's locked, such as GPS or an atomic frequency standard, or cesium, rubidium, that kind of frequency standard as well. But generally it'll be reading inaccurately on frequencies until it's warmed up. I normally give test sets around about 20 to 30 minutes to warm up. If you're buying one of these test sets, there is a common fault on these now, or due to their age. Mullard, an electronics manufacturer in the UK, which is long gone now, manufactured a module called the OM345, which is a wideband RF amplifier, and it looks like a sort of a little thick film module with about 10 legs on it that solders in on the board, and that's the RF signal generator amplifier. And they do fail, but fortunately there are equivalents which can be readily purchased very cheaply from eBay and other sources. So one of the ways to find out if there's a problem with the RF section or any other errors that are in the test set is to first select the help button, and then there's a self-test feature here. So if you just press self-test, it'll run through all its tests. If you select all tests, and now it'll run through a sequence of tests internally within itself, and at the end of it, it'll either pass or fail. Obviously we want it to pass each test. The details of the tests and what they are are actually in the manual for the test set, so you can look those up if any of them fail and find out exactly what it is that's failed. There seems to be plenty of resources on YouTube now with people doing repairs on these, so they are actually quite easily repairable. Parts are quite hard to get hold of, particularly if something's seriously damaged, such as the screen smashed or the buttons or the case parts that are damaged, but mainly the electronic parts inside are still available or equivalents. So as we can see, it's passed all the self-tests. There's no fails in this section. We can now, with confidence, if you were going to buy a test set, you could then go ahead and buy it simply because it's passed all its tests. If it fails any of them, you could run the self-tests again, see if it clears. If it doesn't, then obviously, you know, there is a genuinely permanent fault on it, which will need further investigation if that's the case. So what we will do, we will go now back to where we were to start with. You can set up the instrument as well for different languages, and there are, under the change parameters, all kinds of setups that you can change in there, as well as in the different configurations and such like for the way that the test set's set up. So if we go back to return, we go back to receiver testing for a second. Right, in receiver testing, this is where we're just generating a signal, obviously, out of whichever port we select on the RF port here. The way the test set's designed is that all the scope buttons are in this area for controlling the oscilloscope and the position of the oscilloscope, X and Y. We have external mod input, AF input. We can select between DC and AC. We can actually use this as a voltmeter input from a scope probe. AF gen output, where we can send a signal out. Accessories I'll talk about a bit later that can connect in there. With a high power port RF, which is 75 watts maximum RF, and a 1 watt port which we can select between them. And then of course we've got the increment buttons where we can set up levels in increments. We've got the variable control for adjusting levels manually, with AF filtering, and then down here we've got all the modes in the blue keys, all the functions in the green keys, and then all the data entry keys. One of the nice things about this test set as well is that it's got a power switch on the front, which a lot of modern test sets seem to be going away from for some reason. There seem to be rocker switches round the back, which is quite annoying if you've got them rack mounted or you've got them mounted with piles of other equipment as well. And it's nice that that switch is there. Okay, we've got a volume control for monitoring the transmit side when we're transmitting to the test set, intensity for the screen, so we can adjust that accordingly. Okay, so on the receive test side of things, I'll just set up a basic measurement on this radio, which I've got here, which if I switch it on, let's have a look. Right, so I can set up a test. I can do RF gen frequency 433.5 megahertz in this case. RF gen level, can wind that up, put the low power antenna port on, and wind that up now. So we're receiving a signal. I can set my mod frequency. I can put that frequency to whatever I want. You can change that, and you can put increments in as well if you want. And how you do that is you just press the increment key there, and then you can select 100 Hertz steps, for example, and then you can just press the frequency increment button. So you can do all these kind of tests. You can switch the mod on and off as well. You can do that. There's a lot of testing that you can do on it. You can select oscilloscope. So if we're receiving audio from the radio into the AF input port, then we can read that on the oscilloscope and then do synod measurements and such like as well. Signal to noise measurements, we can do synod, distortion, there's all kinds of measurements that we can do on the receiver. Signal to noise and distortion is where we bring three things together there. We bring the signal, which is a 1 kHz tone. We bring the noise, which is the crackle and hiss on the carrier that we're receiving from the SIG generator at that particular level, and we bring the distortion, how distorted the signal is when it's been received on the receiver. And the audio output is 1 kHz. If it's got crackle and pop and it's distorted, then that's where we get the synod reading. Signal to noise is just where it pulses a 1 kHz signal and switches it off, pulses it, switches it off, and it measures the difference between the signal and the noise, and that again is a separate test. Within this test as well, we can emulate CTCSS tones and cell call tones, so we can go to what is the tones menu, and we can select all kinds of different sequential DTMF, POCSAG for paging, digital coded squelch, and in the mod setup we can set up CTCSS, which I'll go into probably in the next part. The transmit side, we can again select the low power port, and on transmit we can have bar graphs as well, or we can have scope. So if you press the scope bar chart, we've got currently set up a measurement here where you can select the scope to be measure 3 kHz deviation, 6 kHz, 15 kHz, 30 kHz, and it goes even lower to 1.5 kHz as well. So those are the steps that we can look at modulation. Now the test set does FM, it does AM and phase modulation, does 3 different modes which are applicable here. It doesn't support SSB, I'm afraid, but there again, due to the age of the test set and obviously what the market they were aiming at, which is emergency services market primarily, there weren't many emergency service radios that worked on SSB anyway. They were all mainly AM, FM or phase modulation. Now under the transmit test, we can read using this test radio frequency, obviously, RF power as well, mod level and mod frequency, 1, 2, 3, 4, 5. Now we can also hear the modulation by turning the volume up. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. And then if we like, we can also see the CTCSS using these bandpass filters here. So we can either have a 15 kHz filter, which will include everything, a 300 Hz low pass filter. Now if I go to a radio channel which I believe to have CTCSS on, when I now transmit we should be able to see CTCSS. Now if we adjust the scope, and then we can pull that out. So that's what the CTCSS tone looks like. And then we've got the frequency, the CTCSS as well in the mod frequency area. Notice it's not picking up my speech. Now if I go back to obviously a 15 kHz low pass filter, then it'll pick everything up, including what I'm saying with the speech. And then obviously if I want to get rid of CTCSS and just pick out the speech band, then I can do so as well. So that's a rundown of TX and RX. We can go to duplex testing, and in duplex testing you can select the receiver to be on one port, the transmitter to be on the other, as it shows here, BNC or N type, or you can have it just on one port alone, so it's full duplex out of just one port, or out of split ports. Again, you can set up all the same parameters that you did before in receive and transmit testing. The next one is tones. We can have sequential tones. We can set up a mod generator to modulate the carrier with, say, CTCSS tones. We also have sequential tones and the different cell call tone standards or user defined. Again, for example in EEA, You could put in a radial call sign, for example, a cell call tone. And ambulance services across the world still use cell call, for example, for calling mobile. Cell call stands for selective calling, and the different standards across the world that are normally employed. Now if I set up the receiver on this test here, back up to channel 20, which is my test, I've got a carrier on, and then I go back to my tones, sequential, EA, and then I think I can select using mod gen 1, frequency shifter, next page, next tone, right, page 1, tone burst. So there we are. That's an example of that. Likewise on DTMF as well. We could send DTMF tone. So you can do all your DTMF checks. Likewise, when you're also transmitting as well into the test set, and you can also read those tones as well. So when you're actually broadcasting into the test set, you've got a receive data field here. So you could then transmit to the test set now, and if you press DTMF buttons, they'll appear on there as well. So it reads out what you're sending to the test set. Likewise as well, if you were going to send, for example, an EA tones from an ambulance radio, for example, to the test set, it will then list the call sign there when you send the call sign using cell call. So that's a rundown of the tones section. This is a TX monitor, and here we can monitor off-air signals. So I can, for example, enter in a broadcast radio station, for example. I can then select different filters. So you can set RF images upper and lower, different RF filters. And you can monitor signals off air. Very useful for listening to signals off air, you know, as a scanner receiver would do. And obviously that's available on the low power port. Under any measurements, it doesn't matter what measurement you're doing, you can use the oscilloscope or you can use bar charts. And it's the same on the transmit side. Bar chart will show you RF power and then obviously modulation. So again, radio test 1, 2, 3, 4, 5. So that's just reading off a low power port as well. So it's quite sensitive, you know, it's a very good test set to have. And it's like when you're tracing signals as well, if you've got a connection here on the low power port and you turn the volume up, if you then go with the probe near an oscillator, you'll hear the squelch open on the test set and the hiss, and obviously you can hear what's being recovered on the carrier, and it can be quite a very good fault finding aid, and I think that's one of the reasons why they're so popular. Then of course we've got the hold functions, so we can hold a measurement, we can do so many different things. Likewise in receive mode, if you've got an RF gen frequency and level, you can turn that on and off as well, the signal on and off. You can set the mod on and off. You can do so many different things. Synod measurement, signal to noise and distortion as well. There's an AF audio test mode too, which is here, and this is where we can generate a signal on the AF gen output as well. We again have an oscilloscope where we can recover a signal on the AF input, and then obviously look at that on the instrument as to the level and distortion, and then we can apply things like distortion. We can have signal to noise, synod as distortion, all the parameters there surrounding audio test and measurement. we can generate frequencies, we can do all kinds of things. We can also set up increments as well. So we can go RF gen level, for example, and then we can set up an increment. So we just press the increment key and then select that, say, to be 10 microvolts or 10 dBm. Maybe not, maybe 1 dB, and then you can adjust the levels just by holding the increment and decrement buttons down. So you can do all kinds of testing with it. Obviously on AM, the modes of operation, FM, AM and phase modulation, so you could select different modes. So for example, if you wanted to set up 60% mod on AM, RF gen frequency, obviously, then your level. Now obviously once you set up your RF frequency and your RF level, set mod, frequency 1 kHz, level, then say 60% modulation, and now it's producing an AM carrier at 60% mod on the sig gen output. You can also do the same with phase modulation. You can select measurements with phase mod and FM, and you can do that as well with all the other measurements that we did prior to it. So I'll come back in part 2 with perhaps some more detail around individual radio testing using a Marconi 2955R, and we'll do some more testing, the kinds of capability. Now, accessories that come with this are 600 ohm interfaces that you can get, which go underneath. A lot of repeater line cards where they're on landlines connecting to remote hilltop sites, so microwave links operate with 600 ohm impedance. So this is a 600 ohm thing. This deals with 600 ohm measurements, and then obviously transfers the impedance to the low impedance input on the test set. So that allows us to make 600 ohm measurements. And then we've got other accessories which are particularly useful at hilltop radio sites, which is this. This is the Marconi Instruments Directional Powerhead, where we can put a transmitter in here, and then the antenna on the radio mast will be connected there. This model, there are two models, one that does basically 0 to 25 megahertz for HF bands, and then there's this model which does 25 to 1000 megahertz. And basically this accessory turns a test set into a bird through line VSWR meter, and all you do is you just connect that in there, and now it's turned the radio test set into a measurement capability for measuring things like RF power, reflected and forward, VSWR, peak envelope power as well, which is measured there, or CW, for AM measurements and FM measurements, things like that. So there are all sorts of different accessories. There's another accessory which goes under, which is a tray, which I think is called the 2960, and depending on what software is on that tray, you can have MPT 1327 FFSK trunk systems, cellular TAC, SNE TAC systems, and they then connect into the test set. On the rear of a test set is some sockets on the back. If we just turn it round, it is a heavy test set. It's more portable than some of the other kinds of test sets that are available, but on the back we have IF output, then we've got D mod out as well from the receiver within the test set, external frequency standard, which is obviously an external crystal oven, or atomic frequency standard with a 1 megahertz. We've got obviously the DC as well. You can run this from a battery supply of 11 to 32 volts. So if you're in the field and you haven't got mains available, you can run it from basically your car supply or whatever, which is quite good. We've got the fuses to protect it, and then the GPIB, general purpose interface bus connector, and then on the side here we've got air filters and such like. So that's a little rundown of the Marconi 2955R radio test set. I wanted to make it as quick a video as I possibly could, because obviously when we're showing things in you know, in as complicated as these instruments, it's very difficult to you know, to go into every detail about it in such a short video. So I hope you've enjoyed the video. If you like this, there'll be more to come. Please subscribe. I'll do a repair video on a 2955 because I have a faulty one that's got a problem with its display, and I'll do some more videos on test equipment reviews. Thank you for watching. I'll see you in the next video. Bye bye.